Today we're going to be talking about graphing equations in slope-intercept form, and this is a really important topic in algebra. You use this all throughout any mathematical career that you have. So slope-intercept form, y equals mx plus b. Know this equation. Y equals mx plus b. M stands for the slope, and b is the y-intercept. So like, for example, this one that we have here, this example they give us, y equals 2x plus 6. Let's talk about how we would graph that. And I don't have the best graph here, so be patient with me. So what we do is we put down our y-intercept, which is positive 6. 1, 2, 3, 4, 5, 6. We put down that point. And then we count out our slope. Now you count out at least 2 points of your slope. You count out your rise, which is 2, 1, 2, and then right 1. Also realize that when you're counting out slope, you can also go, and it's a positive slope, you can go negative and negative. What I mean by that is I can go down 2, and left 1, and get another point, connect all 3 points, and there you have what that line would be if it were graphed. Okay, so we put down the y-intercept, and then we count out the slope at least 2 times. Okay, write the equation of a line in slope-intercept form. Okay, so y equals mx plus b with a slope of 1/4 and a y-intercept of -1. Then graph the equation. Okay, y equals m is my slope minus b, which is my y-intercept. So I go to my y-intercept, which is a -1. And then I count out my slope. Up 1, right 4. 1, 2, 3, 4. And remember, I can go, if I want to, I can go up another 1, right 4. 1, 2. Now you want at least 3 points on your line. And then we can also go down 1, left 4. And then using a straight edge, I don't have a straight edge on my iPad, I apologize, connect all of your points. Okay, again, I'm going to be looking for at least 3 points. Okay, graphing in this equation. First, we have to put this equation in y equals mx plus b. Said another way, I need to solve for y. So I need to isolate that variable y. So I subtract the 5x over. And then I divide every single term by a 4. Okay, so now I have my slope is -5/4, and my b is 2. So I go up to a positive 2. And then I go up 5. Left 4, since my slope is negative. One of those components has to be negative. So if I go up 5, 1, 2, 3, 4, 5, left 4, and then I can also go down 5 if I wanted. 1, 2, 3, 4, right 4. And then connect those points. Now remember when we talked about slope, we talked about a sloping line, how you're skiing downhill. Make sure that that negative slope, you're skiing downhill. Okay, graphing that equation, y equals 7. Okay, so y equals mx plus b. What do you notice that's missing? There's no x term, which means that it's like 0x minus 7. So I have a line that has no slope, or is a 0 slope, which is a horizontal line. Or look at it this way. Your y's always have to be -7. So I go down to -7. That's my y-intercept, but my y's always have to be -7. So that's what that graph looks like. Write the equation of the line graph below in slope-intercept form. Okay, so to write the equation of a graph, I need my M and I need my B. Okay, well, what's kind of nice is they give me my B. They tell me it goes through this point 0, -3. So my B is -3. Now I have to look and see, where do I have another point? Where does it cross? Again, it crosses right there. So I go up to right 1. So my rise is 2. My run is 1. So y equals, my slope is 2x minus 3. And that is my video on graphing lines in slope-intercept form.